Good day, everyone, and thanks for joining us as we discuss ISS National Lab Research Announcement, or NLRA 2024-1, In-Space Production Applications, Tissue Engineering and Biomanufacturing, promoting applied research and development for regenerative medicine applications, seeking to demonstrate space-based biomanufacturing and production processes. I'm Patrick O'Neill, Public Affairs and Outreach Lead for the ISS National Laboratory, and I'll be one of your hosts for today's webinar. These webinars help educate those of you who might be interested in submitting a Step 1 concept summary for this ISS National Lab Research Announcement. Please note that this webinar is being recorded and will be available on the ISS National Lab website following today's live presentation. Okay, so let's get into a bit of the background and history of the ISS National Lab. The Center for the Advancement of Science in Space, or CASIS, is the manager for the ISS National Lab and has served as such since 2011 through a cooperative agreement with NASA. In fact, last year NASA extended this cooperative agreement for CASIS to manage the ISS National Lab through 2027. Each year, the ISS National Lab puts forth a variety of research announcements focused on targeted areas, soliciting project concepts from researchers, companies, innovators, and educators alike. ISS National Lab research announcements enable greater access to the ISS, a unique platform in low Earth orbit, bringing scientific value back to people here on Earth, building commerce in space, and inspiring the next generation of researchers and explorers. And with that, I'd like to introduce Dr. Davide Marotta, Program Director for In-Space Biomanufacturing for the ISS National Lab. Davide, good afternoon, and excited to learn more about this opportunity.
Thank you, Patrick. Before diving into the research announcement 2024-1, let me say that microgravity allows us to do scientific research in a way that we just can't do here on Earth. Researchers are turning to space for the potential of game-changing results.
Well, let's start that off with the obvious question of why conduct research in space?
Conducting research in low Earth orbit, or LEO, offers several advantages. LEO provides a persistent microgravity environment where the force of gravity is significantly reduced. Conducting experiments in microgravity can reveal new insights due to the reduced interference from gravity-related variables. This can accelerate translational research and biomanufacturing processes on stem cells, tissue engineering research, drug discovery and toxicity studies. Extreme conditions on the ISS are ideal for testing fundamental physics theories. For example, we can use space to investigate the behavior of particles and electromagnetic fields. The unique advantage point provides a global perspective on Earth climate, weather, and environmental changes. Let's talk a little bit about what we are going to cover during today's webinar. We'll dive into the research announcement process and look at some existing ISS National Lab research examples. We'll then provide a short overview of a few relevant facilities on board the ISS and highlight the timeline of this research opportunity. Then, as Patrick mentioned, we'll have a question and answer session. With NLRA 2024-1 in space production application, tissue engineering and biomanufacturing, we aim to accelerate LEO-based applied R&D applications seeking to demonstrate space-based tissue engineering and biomanufacturing technologies and products, enable new business growth and capital investment for scalable and sustainable market opportunities, produce value for the potential to generate demand for and revenue from access to space. In particular, we are seeking proposals in the following areas: reprogramming, expansion, and/or differentiation of stem cells, or the benefit of stem cell research in LEO, the enhancement of 3D human organoids or multicellular systems that can be used for research and translational studies, the development of systems to produce tissue or other biocompatible materials and demonstrate its applications. There are several examples of projects that have leveraged ISS for research focused on regenerative medicine to develop a commercial product. These projects address the challenges of organ shortage, aging, rising cell therapy demand, improved disease models, and the need for clinical relevance. Some of these projects have been sponsored by the ISS National Lab in partnership with a US government agency such as National Science Foundation and National Institute of Health. Several stem cell research projects aim to investigate the reprogramming, expansion, and differentiation of induced pluripotent stem cells, mesenchymal stem cells, and hematopoietic stem cells for terrestrial applications in regenerative medicine. Some work in collaboration with NIH, specifically the National Center for Advancing Translational Sciences, or NCATS, which has enabled significant advancements in the hardware capabilities for utilizing microphysiological systems, or tissue chips, on the ISS. These capabilities have been developed in partnership with the implementation partner community and range from partial to full automation, taking advantage of microgravity as an accelerator of conditions. Some key initial findings include identification of a novel link between the immune system and stem cell senescence, spaceflight cardiac dysregulation in 3D models as demonstrated by 2 different PI teams. These studies and others, supported by the National Institute of Health and National Science Foundation, are ongoing, so we still have much to learn.
There are certainly a variety of investigations that have been conducted on the space station over the last few years that would provide great insight and potential use cases for those interested in participating on this research opportunity. Speaking of, Davide, if a research team is interested in submitting a concept, what other research pathways should they consider?
Those interested in conducting such research could use the opportunity provided through this research announcement to identify ways that tissue chips, platforms, or other biological engineered systems could be utilized in low Earth orbit to drive sustained revenue. This could be achieved by developing platforms for novel target identification, validation studies, or preclinical safety and efficacy. The ISS National Lab has supported several organoid studies. These self-organizing 3D tissue cultures hold immense promise for advancing our understanding of diseases and developing high-throughput disease modeling platforms, particularly in the context of microgravity research. Organoids mimic the natural environment of cells in the body, compared with traditional 2D cell cultures. The cells within the organoids can interact more naturally, forming complex tissue structures and better representing physiological processes. Another aspect of NLRA 2024-1 is biofabrication. This covers a wide range of opportunities such as fabricating tissues for disease modeling, testing of biofabricated materials, and improving fabrication processes for biomaterials. There is an urgent need for tissues, organs, and other biomaterials for transplantations and regenerative medicine applications on Earth. In the past decades, many novel tools have emerged to enable the assembly of these complex structures. There are current and planned commercially operated biofabrication systems on the ISS, including the Redwire Biofabrication Facility, or BFF, shown here. And I just want to remind you that concepts looking to build commercial facilities in this area are within scope of this research announcement. There are advantages to biofabrication in microgravity, including the ability to use less viscous bioinks, enhance cell-cell interaction, control mechanotransduction effects due to microgravity during the maturation curing process, and print simultaneously from any spatial orientation. With these examples in mind, let's talk about the facilities on board the ISS that can support projects awarded through this research opportunity.
So, Davide, where might applicants find information on hardware and facilities available to support their research goals?
The ISS National Lab offers state-of-the-art hardware and internal and external facilities, providing a wide range of research equipment and systems for your R&D in LEO. I encourage applicants to review the facilities using the link provided here and also in the research announcement instructions, and please contact us with any questions about available hardware and facilities. We also ask all applicants to identify an implementation partner they like to work with and start a dialogue about project goals. Implementation partners are organizations with expertise in translating ground-based research for the ISS environment. IPs are your space fairy godmother that will guide you from here to LEO. Since we are discussing costs, this is the perfect time to discuss funding. Connecting with an implementation partner during Step 1 concept summary preparation is critical. please visit our implementation partner database and begin engaging in conversations with them. And you will want to get, a realistic estimate of what your project might cost, especially if you are new to space. Funding for this specific research announcement is up to $750,000, with the expectation of 2 awards. Grant funding may be allocated to support all aspects of the project, including your time, your team's time, equipment, fabrication costs, and testing that you will do on the ground to prepare for space. As I mentioned, when it comes to doing space-based research on the ISS, it's essential to have an implementation partner to work alongside you. Launch to the ISS. The cost of any crew resources that you may need to perform your experiment, and resources to get your samples or your data home to Earth will be completely covered.
Thanks for that deep dive on funding, Davide. I'm sure most viewers are now wondering, how does someone even get considered for funding through this research announcement?
The Research Announcement 2024-1 has a 2-step submission process that begins with the Step 1 Concept Summary. The Concept Summary is a 2 to 3 page summary of your proposal, which is due by November 20th, 2023. Take your time and read through all the Step 1 Concept Summary instructions. During the Concept Summary review, we conduct a high-level review for scientific and technical scope, operational feasibility, and economic merit. And also, we do a preliminary compliance review. If you pass Step 1, we will contact you and invite you to submit Step 2 full proposal by March 11th, 2024. So let's take a look at the timeline. Step 1 concept summaries are due on November 20th, 2023. And if invited, your Step 2 full proposal submissions deadline will be March 11th, 2024. Research Announcement Awards will be selected by May 2024.
Thanks, Davide. Is it fair to say that what you've covered regarding this research announcement is detailed in the downloadable documents and instructions available on the 2024-1 Research Opportunity webpage listed below, as well as information available regarding the evaluation process?
Yes, everything is there with even more details. You will also find the evaluation methodology in the proposal evaluator instructions, and all documents are available for download. As you prepare for your Step 1 concept summary for submission, we recommend you keep in mind a few tips. The current opportunity webpage has helpful information. Connect with an implementation partner early. The scope of work and budget that you receive from your selected implementation partner is critical. Write to the evaluation criteria. The instructions outline the evaluation criteria that will be used to evaluate your concept summary. Address all the evaluation criteria. Proposals that do not address all the criteria or address them poorly are likely to receive low evaluation ratings. Submit a compliance concept. Ensure that your research objectives are within the scope of this specific research announcement. Our team is here to support you. Our website has all documents, instructions, and resources to help you to submit the best concept summary possible. And get ready to take your R&D out of this world. Remember, you can email us at any time. We are available to answer any questions.
Thanks, Davide. To our audience, remember that ISS National Lab activities aim to bring value and impact to the U.S. economy and taxpayers by benefiting humanity. It's been a pleasure talking with you today, Davide. Thank you very much.
Pleasure is mine, Patrick. So what's next? Ready to answer some questions?
We sure are. In just a minute, we'll be taking questions from you, our webinar attendees. Stay tuned.